This video is an excerpt from the ϕPPL Programming Language Lecture Series. Copyright 2013, Technoventure Incorporated. Compare operators. The generally binary compare operators compare two expressions and produce a Boolean result. This result reflects whether the comparison is true or false. 1 means true and 0 means false. These operators are similar to the logical Boolean operators in that they usually take multi-bit operands as values. These Boolean results are often used in the test clause of control structures, but they can also be used in complex expressions and stored in variables. Once again, phi closely follows C in functionality, but the symbols used to represent the operators have been modernized in phi. Because C is based on ASCII, as are almost all modern programming languages, it does not take advantage of the new symbols that are available in Unicode. Not only are the Unicode symbols more familiar to the general public, but they are also more intuitive and take up less space in your source code. There are 6 compare operators in C. The most basic is test for equal. Because the ASCII equal symbol is used as the assignment operator, you must double up this symbol to create the test for equality operator. If the operands are indeed equal, the result of the operation is a Boolean 1. Otherwise, it is a Boolean 0. The antithesis to this operator is the test for not equal, which is composed of an exclamation point followed by the ASCII equals sign. The greater than compare operator returns a 1 if the left operand is greater than the right one. The operator is composed of the ASCII greater than symbol, also called right angle brace. The less than compare operator is the counterpart of the greater than symbol. It returns a 1 if the left operand is less than the right operand. In like fashion, the greater than or equal compare operator returns a 1 if the left operand is greater than or equal to the right operand. This operator is composed of the ASCII greater than symbol followed by the equal symbol. The less than or equal compare operator is the counterpart of this operator, and it is composed of a less than symbol followed by the equal sign. While the greater than and less than operators are counterparts to one another, they are not each other's opposite tests. Just as it takes a test for not equal to get an opposite result for a test for equal, it takes a test for less than or equal to get an opposite result for the greater than test. Furthermore, it takes a test for greater than or equal to get an opposite result for the less than test. It took a long time for me to get used to the equal operator in C. Beginners tend to write just one equal sign, which ends up being an assignment. Because assignments can happen in the middle of expressions in C, you often end up with a syntactically correct statement and no warnings or errors by the compiler. After discovering that the program does not behave correctly, it takes some close examination to discover what went wrong. Phi implements all of these compare operators with a single character in each case. So the compare for equal operator is just a single equal sign. Those of you who are so entrenched in the double equal symbol, which is used in C++, C#, and Java, will be informed by the compiler of the error if you accidentally place a double equal symbol in your program, because it does not mean anything in phi. The equal sign is not an assignment operator, and it is never anything other than the compare for equal operator. The compare for not equal operator, then, is a Unicode not equal symbol in phi. Continuing on, the test for greater than operator is the ASCII greater than symbol as it is in C. Likewise, the test for less than operator is the ASCII less than symbol as in C. The test for greater than or equal compare operator is the Unicode greater than or equal character. And finally, the test for less than or equal compare operator consists of the Unicode less than or equal symbol. So this table lists the 6 comparison operators in C and phi. In both languages, the operator precedence for equal and not equal is lower than for the other 4. Also, the precedence for the compare operators as a group are higher than for the logical Boolean operators as a group. Now you might ask, why do we need different precedence for the equals and not equals operators, and why would their precedence be lower than for the others? This example should demonstrate why this is. It should not be too hard to see that the expression assigned to A will yield the opposite result if we replace the test for equal with the logical XOR. Besides the 6 compare operators discussed above, phi has 2 compare operators to support fuzzy logic. Frequently, 2 floating point values that are nominally the same can fail to compare equal to each other just because of rounding error. It is often the case that in engineering, a measurement is considered to be equal to a value if it is within tolerance of that value. So we have the test for approximate equality. The way we write this in phi is to write the first operand followed by the Unicode approximately equal symbol, followed by the second operand. This is then followed by an auxiliary operator, the Unicode plus or minus symbol, then followed by an error or tolerance operand. To obtain the antithesis to this operation, replace the Unicode approximately equal symbol with the Unicode approximately not equal symbol. The precedence of the approximately equal, not equal operators, along with their plus or minus auxiliary operator, is the same as that for the compare equal and compare not equal operators.